everyone, and welcome to another Microsoft Reactor live stream. We are live from Dubai, the UAE. Thank you all so much for joining us online. Please let us know in the comments before we begin where you're joining us from, which country you're seeing us from. We would love to know where our worldwide audience is joining us from. So please let us know in the comments. And that being said, today is the final episode to our machine learning for evolving applications series, which we've done over this month. This is the final episode where we will be kind of taking all the knowledge that we've learned in the last two sessions and just kind of showing you everything from how to build your first machine learning model, of course, through a hands-on approach. So we're going to be talking more into details with this one. But before we begin, obviously, as you all know, this event is part of our Microsoft Reactor Code of Conduct. So obviously, we're all here to learn. So, let's be welcoming, let's be respectful. Most importantly, let's be open to kind of all questions and viewpoints. The chat box is open for you to kind of ask any questions, or if you have any comments or suggestions, please let us know. I'll make sure to answer as many questions as possible by the end of the stream. That being said, if you've never been here before, if you have never seen any of my streams, to introduce myself, my name is Hadil Shubair, and I am a cloud advocate at Microsoft. I am based in Dubai, in the United Arab Emirates. And part of what I do as a cloud advocate is obviously I'm very passionate about kind of sharing knowledge and basically talking about everything that's in tech. So I'm all about kind of, building communities right now. I have an ongoing series and an ongoing community, which is all about Arab speaking women in tech, where we kind of host inspiring women who are in the field, kind of to talk all about their experiences, their skill sets, and also to kind of, guide, the audience on, kind of their skilling and tech journeys as well in different topics such as AI, machine learning. We have also into cloud computing, Internet of Things, Microsoft Azure, and so much more. I am all about empowering women in tech, and I absolutely love to always share kind of everything that's going on new in all things tech. If you'd like to kind of connect with me and see what I'm up to, my LinkedIn handle is Hadid Shubair, just like my name, and my Twitter handle is @Shubair3. So, of course, feel free to connect if you have any questions after the session or during the stream and maybe I missed it. Feel free to connect with me on LinkedIn and I will be happy to, or on Twitter to kind of answer any of your questions. That being said, let's look at our agenda and what we have on for today. So for today, I'm going to briefly take you through the machine learning process. So obviously, in the last two episodes, in the first episode and the second episode of this machine learning for evolving application series, we talked about everything from basics, foundations, the different types of learning you have, the different algorithms, how to choose the best machine learning algorithm for your kind of your problem, and how to kind of differentiate between all these kind of tech concepts. Today, we're going to be talking about the workflow of the machine learning process. So basically, I'm going to be kind of telling you what stages you need to know to actually start building your machine learning, your first machine learning model. Now, just keep in the back of your head or the back of your mind that every machine learning model or building, each machine learning kind of project is different from one another. However, there are kind of initial steps that you really need to keep in the back of your head as you actually go through each of those projects. So I'm going to be taking you through kind of the workflow of machine learning and taking you through the steps. Next, we're going to be moving right in and kind of I'll be showing you how to build your first machine learning model through a hands-on approach. We have an example, and I'm going to be showing you exactly what steps, after everything that you've learned in this session and the previous sessions in the series, as well, how you can actually apply all that knowledge and take it into action so you can actually have the confidence to start, building your own project as well. Then I'm going to be kind of briefly talking to you all about machine learning on Azure or Azure AI as well. So obviously Azure is Microsoft's cloud computing platform, which has different and many solutions and services such as compute, networking, storage, analytics, and so much more. So I'm going to be taking you through, how you can use Microsoft Azure to actually help you build and deploy and even train your machine learning models if you don't have the experience or basically if you would love to kind of explore the platform more. Lastly, from my expertise point of view, I'm going to be give you my best tips and tricks on how you can actually get started in the machine learning or AI field. So if you're a beginner, if you're a student, if you're someone who's only shifting careers, if you're someone who actually is just genuinely curious, or you would love to learn how you can actually get into this vital field, I'm going to be giving you my best tips on how you can actually get started. That being said, let's actually jump into the first kind of objective of what you have today and explore the machine learning process. So obviously, if you've already been here and you've watched kind of this series and what this series is all about, we explored everything from kind of the world of machine learning. Now, it's very important to know that, when it comes to, building your first machine learning model, or you have a project in hand, you want to kind of, you have a prediction problem, a regression kind of problem, or a classification problem as well. Whatever really your goal is or objective, it's kind of the steps stay the same. So let's actually start by exploring what these steps are that you need to always keep in the back of your head as you begin building your model. So this is how what you have in front of you, how the machine learning process actually looks like. Now, as I mentioned before, it differs from one project to the other, but these are kind of the steps, these necessary steps that you need to always keep in the back of your head as you're going through from one project to the other. So the first step to building, any machine learning model, yes, you have a problem in hand and you want to kind of, let's say you want to classify between two categories, or you want to predict the weather forecast, or you want to kind of you have a specific goal. You need to be very clear with what your goal is. So the first step in building in the machine learning process basically is to define your objective. So you need to have a clear kind of statement or a goal statement basically that kind of defines exactly what it is that you're trying to achieve by the end of this project. So you need to kind of base off your goals on this and kind of be very specific about what your goal is, and just keep it in the back of your head that your target should be, you need to have actually one goal. So you can't have like specific goals because it would be very confusing and such. So make sure to have only one goal that you want to achieve by the end of this kind of process. So after you've clearly defined your objective, you know exactly what you want to start kind of solving. The next step is to obviously start by gathering your data. Now, it's very important in this step that the data that you collect should be coming from a reliable source. So, you have primary sources, you have third party, and such. So you need to make sure that this data is reliable and is actually also obviously related to what your goal is. So let's say you want to predict kind of, let's say, the weather forecast. So obviously you're not going to be getting, your data set should be all about the weather conditions and the climate changes and such. You're not going to be getting data that is all about gardening, for example. So you need to make sure that this data set you have in hand is actually obviously kind of related to what your goal is. After you've collected your data and all that stuff, now you are ready to prepare your data. So what do we mean by data preparation? With data preparation, we mean obviously, real world data is extremely messy. So as a data scientist or as like a machine learning engineer, the data sets that we always get, on a daily basis are absolutely messy. And what I mean by messy data is that this data set should, it always has kind of missing errors, duplicates, inconsistencies, just kind of some kind of, let's say, like values that don't really make sense. So as a data scientist or someone who is, wanting to build your first project, this actually step takes the most, it takes actually most of our kind of time. It's very time consuming. However, it's very important to make sure that your data that you have in hand is treated properly. All those incorrect or inconsistent or duplicates or irrelevant values are all kind of treated correctly. Like you can remove unused rows or columns that you don't need, and treat also obviously any null values that you have. So you need to make sure that your data is cleaned and pre-processed before it actually moves on to the next step, which is obviously the model and the algorithm and all that stuff. So you've defined your objective, you've collected the data that you have in hand, you've made sure that your data is clean, it's ready to go, it's good quality. And what is the next step? The next step is to actually choose your machine learning algorithm. So to choosing the model actually requires a few steps. So it depends really on the data that you have in hand, on your goal, and what it is that you're trying to achieve. So if it's, let's say you want to predict something, you want to predict, let's say, the price of a house, or such. If it's something that has to do with prediction, then you are going to be using one of the regression algorithms. If it's, let's say you want to classify an object into two categories, let's say you have a list of students and you want to classify them from males or females, for example, and such, then this is a classification problem. So you would be using classification algorithms. So really, depending on what your goal is, and we obviously covered the most popular machine learning algorithms in the last session, you need to choose the algorithm that you want to build. That is basically kind of related to what your goal is. Next, you will be training your model. So most of the data set that you have in hand that we've already collected, you will be splitting that data set into a training set and into a testing set. The training set will be kind of used for, basically your model to actually be trained, and it will start learning from the data that it has, and, kind of to be learning on its own to be able to give you the output that you ask it to kind of, give you. And then you will actually, after it goes through the model training, the next step is to actually test your model performance. So you want to see how well your model is performing. And in the train and testing kind of sets, the training set will be, used for a kind of, let's say, a ratio of 70 to 30 or an 80 to 20, meaning that most of your data set should be taken into the training kind of set, and only the rest 20% or 30% will be going to the testing, because you need most of your data to be able to teach your kind of model to learn on its own. So we will be testing the performance of the model. After you test the performance of the model, we will evaluate our model. So depending on, what you can do is you can actually start here in the step giving your model and feeding it new unseen data or input data, and based on that it should be able to give you the result that you're looking for. So let's say you want to predict the weather forecast. So you tested it. Now to evaluate it, you will give your model whether the new unseen weather data that you haven't put in before, and based on that the model should be able to give you the kind of correct answer to that. So if it's working correctly, then your model is good to go and you are done with the machine learning process. It will be able to give you the predictions that you want. If not, you can actually tweak your model by using specific hyperparameters and such that will kind of help your model go through several steps and several rounds to actually learn on its own. And you basically kind of give your model feedback, because obviously, as a data scientist or machine learning engineer, you know what the answer is. Based on that, your model should be able to give you predictions on any new unseen data. So this is basically the machine learning process or workflow in a nutshell, and this is basically the steps that you need to always keep in the back of your head as you go and build your first model. Now, let's actually move on to the kind of, good part of it, and let's actually look at a hands-on example and approach on building our first model. So I'm going to be going now to the actual example here. And this is the example that we have here today. So today we will be our example that we have is we will going to be predicting the medical insurance cost for an individual. So in this example, basically we have a data set of insurance data, and basically by the end, our objective by the end of this kind of example is we want to build a model that will help us predict the cost of treatment for individuals based on several features in the data set, such as their age, the BMI, and other information that we have. Let's actually begin by exploring our data set and see what do we have in our data set. So the first thing that we're going to see here is the data set that we have in hand is we have age, we have the sex or the gender, we have the BMI, the body mass index, children, smoker, so if the individual is a smoker or not, the region, so where they are, the residential area they are in, and the charges or the cost. So as I mentioned before, our objective, and always keep this in the back of your hand as you are going through the steps, our objective is to predict the medical insurance cost. So what will be our target feature? It will be charges. So this is basically the kind of the goal or the kind of target feature that we always have to look at in this data set. So now that we've actually had just a quick overview or idea of what our data set consists of, let's actually start by beginning. So the first step that you need to do here is you will have to load your data. Now, by loading our data, you will have to import the necessary modules or libraries. And this is kind of a step that you always have to do. So if you're using Python, you need to actually use, libraries. So Python, I always recommend, Python as the go-to language for you to use when it comes to building your first machine learning model and such, because it's very easy to use. It has tons of excellent libraries that you can use that can help you with data visualization, analysis, computing, and much more. So you will start by loading your data and importing the necessary libraries or modules that we need. So we're going to be using NumPy for kind of scientific computing, such as anything from vectors and matrices and linear algebra. We're going to be using pandas to use for reading our data, manipulating our data, and analyzing our data. And we're going to be using the matplotlib library, which is used for data visualization. So to do that, we're going to write our lines of code here. So we're going to be importing these libraries, and then as soon as you run your code, it will show here that you've imported the necessary libraries and they are already installed into our environment. So we've imported the necessary libraries. Next, we will load our data as we've already done. Now, if you already want to see of how like an actual kind of example of our data set looks like, usually it would look like this. So our data set could look like something like this. We have all the different features or columns here, and we have everything from the rows or the actual, the entries, the data entries for each row. So this is what our data set looks like. Now, instead of obviously looking back and forth and going from, your environment to your data set, what we'll be doing is you can actually start by you can use the data.head function to help you display the first 10 rows that you have here. All right. So first of all, so you're going to be installing obviously and putting in your insurance data set that you have and reading it in pandas. After you've done that, we want to display the first 10 rows of our data set just to have an idea of how it looks like. So to do that, you will use the data.head between brackets 10, so to display the first 10 rows function. And after that, after you run this line of code, it will give you and display the first 10 rows for your data set. So obviously here you can see the rows and the columns and the different entries that you have. Next, we will start by doing an exploratory data analytics or an initial high-level data exploration. Now, this step is actually very important because, before you actually go through the data preprocessing or data preparation and data cleaning step, it's very important as a data scientist or as someone who's building your model, you need to actually start by exploring what your data set is in hand, your objective, what targets that we have, and basically just to kind of have an overview of what our data set looks like. So to get a clear overview of our data set, we're going to actually be seeing how many rows and columns we have in our data set. And instead of actually going to our data set to actually count how many rows and columns we have, you can actually use this function here, which is where you specify the rows at the data shape of the rows as 0 and the data shape for the columns as 1, and it will basically print for you how many rows and columns. So simply by running these two lines of code, it will show us that we have 1,338 rows and 7 columns. So I'm just going to be zooming in here just for one more kind of quickly, just for you to see and make sure it's clear. So we can see that we have 1,338 rows and 7 columns. Next, we have, obviously, as I mentioned, in Python, we have so many amazing functions that you can use that will help us, obviously, see different kind of information that we want. So using the function info that we will run here in a bit, it can actually show you several tasks that you have. So it can show you the different data types that you have for each of the features. If it's a float, if it's an object, if it's an integer, and such. The how many missing values you have, the memory usage, and also the different number of rows and columns as well. So we are actually going to be using the data.info function and running this line of code simply to give us what we can see here. So after running the data.info kind of line of code, we can see obviously here the different columns that we have, the number of rows or entries and the columns that we have, a total of 7 columns. Obviously, as I mentioned, the type of each column that we have. So this age is an integer, the gender or sex is an object and such, and also the memory usage. Now, it's very important to realize here as well that as you can see, all of these kind of columns have 1,338 obviously entries. However, if you focus here, you can see that the BMI column has 1,335. And that means here we have three missing values. So what does this mean? That means when we move on to our next step, which is data cleaning and preprocessing, we need to make sure that those three missing values are treated. So this is just something to keep in the back of our heads, and this is why I love to use the data.info function to always give you it gives you kind of a heads up beforehand that you have three missing values and such. So we need to make sure that those need to be treated. So we've seen those, and then we will move on to using the data.describe function. The data.describe function basically it shows us everything from kind of everything from the mean, standard deviation, the maximum and the minimum of each numerical feature, as well as the first quartile, second quartile, and third quartile for each of the columns that we have. So we will actually run this line of code, the data to describe function, and it will actually show us everything we need to see here. The 25% is the first quartile, second quartile is the 50%, and 75% is the third quartile for each of the columns that we have. So here, this basically summarizes the function or the line of code that we have. Now, at this stage, we've actually kind of got a clear overview. We've done our exploratory data analytics. We've kind of, had a high level kind of, kind of view of, the data set that we have in hand using the functions info and describe as well. Now we are ready to actually visualize our data set to actually help us see kind of preliminary insights on our data set. So it helps us basically see all those numbers into graphs and plots, and this is basically it will help us as engineers or data scientists and analysts to actually understand exactly what data set we have in hand. So we're actually going to be starting by actually plotting and looking at the distribution of charges. As I mentioned, our goal in this building machine learning model is to actually predict the medical insurance cost for each individual. So our main kind of target is our main feature that we want to always look at and kind of have in the back of our head is the this charges actually category. So we want to actually look at distribution of charges and see how much patients actually spend on their treatments on average. So to do that, we're actually going to be plotting a histogram. To plot a histogram, you will basically first of all, you're going to be telling your model that the model that you want to plot is actually a histogram, and you will be plotting the charges using the features or the charges feature or column. Next, you're going to specify the title of what your histogram is going to look like. So it's going to be distribution of charges and the X label and the Y label. So the X-axis is going to be the charges here, and the Y-axis is going to be the frequency. Next, you're going to be showing, you want us to show the results of what we just ran. So we will run this line of code, and this is basically what it will give us. So as we can see here, from this graph here, this is the distribution of charges. We can notice, obviously, from this plot here that the lowest charges here are spent by most of the patients, whilst the highest charges are spent by very few patients. So this is what we can tell from the distribution of charges. It just gives us kind of an overview of the different, how much patients spend on treatment on average. Next, we want to actually start by seeing the correlation of several features. Now, keep in the back of your head that, as you're going through, building your model, you actually want to see if there are any relationships or correlations between any of the features that you have. So we want to start by seeing, obviously, since our goal is to predict the medical insurance cost, first we want to see if smokers spend more or less on treatment than non-smokers. So we want to see the correlation between smoking and the cost of treatment. Now, before we do that, let's see how many smokers and non-smokers we have. And instead of going to the data set and counting, how many smokers we have and how many non-smokers we have, we can simply run this line of code here, where we actually specify and select the smokers column. So we will specify it here, and we will specify if they're a smoker, it will be yes. Non-smokers, it will be a no. So by running this line of code here, it will tell us that we have 274 smokers and 1,064 non-smokers. After we've done this, we want to plot the charges for both smokers and non-smokers. So to do this, we're actually going to also plot the charges for both. Now we want to create the figure here. So we will, just like before, set the title, the x-axis, the y-axis for both of the kind of the plots that we have. And after running this line of code, it will show us the distribution of charges for the smokers and the distribution of charges for non-smokers. Now, if you look at these two kind of plots here, side by side, we can notice that the majority of the smoking patients here, so the majority of the smoking patients actually spend around, maybe let's say an average of $20,000 on average on their treatment, compared to actual non-smokers who spend way less. Let's say they spend from $2,000 to $5,000 maximum. So we can obviously kind of confirm that smoking patients actually spend more on health treatment due obviously to kind of any health issues they've already had or any kind of medical history as well. So this is basically the distribution of charges for both of these features. Next, we want to see if there is a correlation between the age and the cost of treatment. So to begin with, we want to actually see the distribution of the age alongside in our data set. So let's see how many, most of our patients fall underneath what age. To do that, we're going to be plotting a histogram as well. To see obviously the age distribution. As mentioned earlier, we're going to be basically specifying the type of which feature we're going to target here to plot. So we want to plot a histogram for the age feature. Next, we will specify the title. It will be age distribution. The x-axis will be the age, and the y-axis will be the frequency. And then we are going to show this histogram. To show this is basically the age distribution that we get. So we can mention and see here that most of our patients in our kind of data set are here fall underneath kind of mostly are between the ages of 18 to, let's say, like a 22. So they're mostly young that we have here. Next, we want to see how age actually affects the cost of treatment. So to see how the age actually costs or affects the cost of treatment that we have, which is our target goal, we want to plot the correlation between age and cost of treatment. To do this, when you have kind of two kind of target variables, it's best to actually see a scatter plot. So we're going to be plotting a scatter plot to show the correlation between these two features. And in the scatter plot, it basically works the same. You actually specify obviously what your features are here. So we want to target age and charges, and we will plot the plot will be a scatter plot. Then we actually specify the title, the x-axis, the y-axis, and we show this plot. And this is the results that you get after you run this line of code. So as we can see here from this, cost of treatment for different ages kind of, scatter plot here, that obviously the more obviously patients the older the patients get, the more obviously they have to spend on health treatment, obviously due to any kind of medical history and such. So it all kind of makes sense and kind of confirms with what we're doing, basically. Now we are actually going to check if also smoking also affects kind of ages as well. So we're going to be showing a scatter plot, which shows the, kind of the difference or relationship between age and the cost of treatment, while showing smokers in red and non-smokers in blue. Now this will actually just show us kind of the correlation between if smoking also affects this curve. So here we have the cost of treatment for different ages. After running this line of code, it will show us that non-smokers who are in blue, kind of spend less on their health treatment than smokers who are in red, who obviously spend more charges and more on their treatment, which also confirms our previous findings and what we have done before. This kind of gives us an idea to see basically if our model is performing correctly and such. So as I mentioned, you would actually kind of have to kind of think about it on a high perspective, that it actually confirms and it actually makes sense that smokers actually spend more on health treatment. So it actually confirms with our findings and what we have found, as we have seen. Next, we want to actually see if there is a correlation between the BMI feature and column and the cost of treatment or charges column. So to calculate the body mass index, which I'm pretty sure most of us know, it is the weight over the height squared. So now let's look at a quick kind of BMI chart here as a guide to just know the different categories for the BMI kind of categories that we have. So if a patient is underweight, they will be falling underneath the category of 12 to 18. If they're healthy, they will fall from the range of 19 to 24. If they are 25 to 29, they're overweight. 30 to 39 is obese, and extremely obese if they fall underneath the range of 40 to 42. So this is just as a guide. I put it here just for us to keep in the back of our head as we go through our findings. Now we want to actually look at the distribution of BMI in our data set. So let's see, most of our patients fall underneath, underneath what category in the BMI area. So to do that, we're actually going to be also plotting a histogram to show the distribution of BMI. So just the same, you would actually specify that our category and the histogram that we want to plot is the BMI distribution. And then we will plot the title, obviously specifying the x-axis and the y-axis. And based on that, we will actually see the distribution of the BMI of most of our patients on our data set. So obviously from our findings here, what you can actually see that the highest number of patients that we have fall underneath kind of like a 27 to 30. And if we go back to the guide here, at 27 to 30 means that most patients fall underneath the overweight to an obese kind of categories. So this is actually, what we can see from the BMI distribution. Now, according to the BMI chart that we've already seen obesity, the obese category starts at BMI 30. So we want to actually start by investigating more and seeing the impact of BMI on the cost of treatment. So does BMI actually affect the charges or the cost of treatment for individuals? To see that, we're actually going to be running a few lines of code here. So the first thing we're going to be doing is we're going to be specifying the categories for each of the BMI categories that we have. So if a patient is obese, they're going to be falling, they're going to be, either having a number from 30 or more. If they're overweight, they're going to be, greater than or equal to 25 or less than 30. And healthy is going to be the same, so less than 25 and more than 18. And underweight is less than 18. So if a patient is, let's say, 17, we know has a BMI of 17, then we know that they are underweight and such. So we're basically here just specifying the different categories that we have. And this actually, we want to be kind of obviously more specific to see the different, what most of our patients in the data set fall underneath which category in BMI. So after running these lines of code and specifying, obviously, the different categories that we have, as we've seen from the chart above, we can actually confirm that we have 705 people who are obese, 385 are overweight, 230 are healthy, and 15 are underweight individuals. Now, we can actually also notice that most of our patients fall underneath the obese category, and the least ones are fall underneath underweight individuals. And if you actually go back to the chart here, we have also an extremely obese category. So this is not included. So we just don't include it anymore in our data set because we don't have any patients who fall under the extremely obese category. So now we want to actually, after running this and kind of, being able to be more specific and understanding basically most of our patients fall underneath which range, we want to actually start by comparing. So we're going to, what we will be doing is we want to plot the distribution charges for all the 4 categories or groups that we have. So obese, overweight, healthy, and underweight in a specific plot, while showing the different categories in different colors. So obese will be shown in red, overweight in yellow, healthy in green, and underweight data in blue. And what this does is just basically shows the distributions of charges for all groups, but in different colors, just for us to get an idea of, most of our what most of our patients have. And as we mentioned before, most of our patients are obese here. So 705 are obese. So you would obviously see the obese data in red going to be much more in our graph. Obviously, we've plotted our histogram here, and we can see, and it can confirm to our previous one, that most of our patients are obese. And here we can also see that patients with a BMI above 30, so more than obese, spend the most on treatment. So obviously, as they go up and as they have a BMI that's higher, that means they will have to spend much more money on obviously their health treatment and such, which actually completely makes sense. Next, we're actually kind of done with kind of exploring our data and actually doing some data visualizations to better understand the different distributions of the different features that we have and correlations between specific features to better understand what we have in our hand. So this is where we actually move to the next step, which is actually preparing our data or data pre-processing and data cleaning. And this is, as I mentioned, this is basically the step where we have messy data and we actually, use specific kind of methods to help us deal with missing data, duplicates, unused columns, converting categorical data into numerical values, and also making sure that our data is normalized or standardized, meaning it is between the values of 0 and 1. So as we actually explored our data set that we have in hand, we want to, as we mentioned before, if you remember in the beginning of this kind of model, we realized that we had three missing values. Now, let's actually start by seeing how many missing values we have in each column. So so here, by using this kind of line of code, data.isnull.sum, it actually shows us how many missing values in each column. As we mentioned before, the BMI column has three missing values. Now, obviously, there are several ways to kind of treat or work around missing values. But one of the many ways that we can use is to drop rows with missing values. So we will use the data.dropNA function that will help us kind of drop the missing values. And this actually confirms that the BMI column, that the missing values are actually dropped. Now we don't have any missing values in our data set. We will be using the data.info function as well to kind of confirm that we don't have any missing values and to see the different objects that we have and such. And this actually confirms to our findings that our data, we don't have any missing data or missing values anymore. So as we can see here, we have 1,335. So all our data is the same. We don't have any missing values. And this confirms to what we just did. Next, we will be removing unused columns. So this is part of the data pre-processing and data cleaning step. And what this actually does is when it comes to actually, data pre-processing and data cleaning is usually if you have, kind of columns that don't really make sense to your findings or don't really have an impact on what your actual goal is or objective is, usually the best thing to do is basically to remove those kind of columns since, our kind of model can focus more on our target features. So, but be careful before you do this. Just make sure that you completely won't be using or impacting, obviously, your data set that you have in hand and what your goal is. So, in our obviously example here, we said that our goal is to predict the medical insurance cost for patients, for any new patients. So if we actually think about it, the region column and the children column don't really make sense and don't have an impact much on the medical charges of patients. Therefore, we're going to be dropping these kind of two columns that we have here. So we're going to be using the data.drop function, where we will specify what columns that we want to drop, which are region and children. And this actually shows that you are confirming that you want to actually drop them. So by running this line of code and using the data.head function to display our new data set, you can actually confirm that we don't have a region column here and we don't have a children column here. We only have the age, the sex, BMI, the smoker, and the charges columns here. Next, we want to convert categorical columns to numerical. So what do I mean by this actual step? So if you can see here in our data set, the sex column has a female and male kind of data. And the smoker column also has a yes and no data. Now, when it comes to building your models, when it goes through analysis, our models need to only work with numerical data. So it's very important to convert categorical columns to numerical columns so our model is able to process what it is that you're trying to do. So we will convert the sex column or male and female to 0 and 1, and the smokers yes and no to 0 and 1 as well. So we will start first with the first column, which is the sex column, and we want to convert these categorical columns to numerical. To do that, we will actually define what and specify what our column is here. So we will specify that the male will be 0, the female will be 1. And then we will replace this, we will specify that we want to replace this column with a 0 and 1 by running this line of code. And lastly, to verify, we will use and print the data.head function to show us that, these columns have been converted to numerical. After we've printed this and we've run this line of code, we can confirm that the categorical has a kind of columns have been changed into numerical columns. Now they've changed into 1 and 0. So obviously, if it's a 1, it's a male, and if it's a 0, it's a female, or vice versa. Sorry, if it's a 1, it's a female, as we've specified here, and if it's a 0, it's a male, and such. So we're going to be doing the same for the smoker columns. So by also specifying if they are a smoker, then there it's going to be specified as 1, as yes, and no is 0. We're going to be running the exact same line of code here that shows us, to verify our findings, and we can confirm here that also the smoker category is also converted to numerical as 1 and 0. So now here, after running the data.head function, we can actually confirm that all our columns, we don't have any kind of any more categorical features or columns that need to be converted. The last step basically is to normalize our data. Now, it's very important in our data sets to make sure that all our columns are, between the ranges of 0 and 1 and standardized. The first thing we have to do is to get the maximum of each column. To do that, we'll use the data underscore max equal data.max function. This will actually display the maximum value for each column. After that, we will divide each column by its maximum value by using the data.divide function. That will actually help us make sure that our data is normalized and standardized between the values of 0 and 1. And also, this is part of the data preprocessing and cleaning step, which we need to always remember. So we need to make sure our data is normalized between 0 and 1. And here we can confirm, after running this line of code, that all our data here is between 0 and 1. Now that we're done with all these steps, we've explored our data, we've done all the data visualizations for the different distributions that we have and the relationships between target features and such. And also we've done our data cleaning and preprocessing. Now we move on to kind of the mathematical component of this and analysis kind of step. So we move on to the data analysis and processing step. This is where we actually start by selecting what is the right machine learning algorithm or model that we want to use to help us with the outcome. So in this example, what we'll be using, since it's a prediction problem, we want to predict the medical insurance cost of kind of patients, we will be building a multilinear regression model. So it falls underneath the regression algorithms or regression models, because with regression, we actually are predicting. So we're going to be building a multilinear regression model to help us predict the cost of treatment of any new incoming patient. Now, as I mentioned, once you actually decide what your model is, the first thing we're going to do is we're going to split our data set. So most of our data set, or like 80% of our data set, or 70, is going to be going for training, and the rest is going to be going for testing. So by running this line of code where you where you split your data set into an 80-20 ratio here, we've identified it into an 80-20 ratio and such, we will make sure that our data is split. So after we've run this line of code and we've split our data set, obviously we have, instead of having one big data set, we have two different sets. We have a training set and a testing set. So the training set we got has 1068 entries, and the testing set has 267 entries. And each set also has 4 input features, and the input features here, you can see them, which are the age and the sex and the BMI and the smoker, and one output or our target kind of feature, which is the charges. So now, since this is a linear regression problem, we are actually going to build the model, and this is where we actually train the model and do all this stuff here. And then after you've kind of trained the model here, you can see this is where you actually evaluate the model. So you specify that it is a multilinear regression model. Next, you will be evaluating your model using the evaluation metrics that you have here. So to do so, we have to calculate the predicted values that we have on the testing set. So by running this line of code, we can see what are the predicted values we have on the testing set. After that, we want to see what are the number of examples we have in the testing set. So by running the test.shape kind of function here and this kind of line of code, it will show us that we have 267 test examples. So next, we will start by actually specifying and seeing. So you've trained our data, you want to test your data. To test your data, you want to actually use some specific, let's say, parameters that really help with understanding, what the least, error rate is in your data. And always keep in mind that the smaller the error rate, the better the model is performing. That means the model is performing in a good way. So we want to see what the mean absolute error is. To do that, we will print this line of code, and it will show us here that the mean absolute error rate is 0.066, which is excellent. We also want to calculate the mean squared error, which will also, by running this line of code as well, which is used for the mean squared error, it will show us that you have the error will be a 0.0083, which is also a great number, and it's very close to no errors. Lastly, we will calculate the root mean squared error, which which is also another metric we can look at to help us with evaluating our regression models. So we will run this line of code, and it will show us that we have a 0.091 kind of number or error rate. So obviously, since these numbers are very close to zero, that means our regression model is performing very well. So the smaller these errors are, the better our regression model is performing. Now, to validate, we move on to our final step. So this is where you actually use kind of unseen data that you haven't already input before, and you kind of bring in new patients to your model to actually start to help us. You kind of help with predicting, their medical insurance cost. So we will actually here define our model, and we will train our model to make sure that the model is trained, and once you actually input kind of any new data, it will be able to give you the data that you have. So we can confirm that our model has been trained. It will show us the importance of the different features that we have that affect obviously the charges. So we can see here that also the smoker kind of category is the most important one, and is actually the one that affects the charges the most. So here, this actually shows that everything is working perfectly and everything is working correctly. Lastly, we will start by obviously evaluating our model, and this is where I mentioned you will actually um, start by actually calculating the predicted values for this model. So for this new data that you have, we will also evaluate the model using the sklearn library to help us get the error metrics that we have, such as the mean absolute error, the mean squared error, and the root mean squared error as well. And we can see the numbers here as previously mentioned before. So obviously, since we can see, obviously, as mentioned before, these values are very close to zero, and they're very close to what we got from the model that we built ourselves as well. So that means our model is excellent and is performing very well. And since our data set obviously is normalized, so it's between like a 0 and 1, as we mentioned before in the data pre-processing, we normalize our data. We made sure everything's between 0 and 1. That means if the root mean squared error is close to a 0.091 or a 0.092, and a mean squared error of 0.083 or 4, and a mean absolute error of 0.066 are very close to zero, they're considered excellent results. That means if you bring any new incoming patients to the model, it will be able to predict the medical insurance cost for this model. And we can say that this is a well-performing model for this regression example or use case. And of course, as I mentioned before, always keep in mind that the smaller error, the better. So this is basically the example that we have for today. This is basically kind of summarizing the steps on a kind of high level, just for you to basically understand what are the steps you need to take to help you build any kind of machine learning model that you have in hand. So now we will move on to the slides to actually see what we have next. Now, obviously, I've taken you on a high level, obviously, since we have an hour to cover everything. It's very important for you to know that if you are someone who is maybe, let's say, only just beginning into the machine learning field, and you have a model that you want to build and deploy and train, you can actually use Microsoft Azure as your first guide, as the cloud platform that can help you actually deploy and train and monitor your machine learning models. So you can actually learn how to train your models with Azure machine learning and explore the different training methods that we have on the Azure platform that we have on Microsoft as well. So On also obviously as part of Microsoft Azure, we have the Azure Machine Learning Service, which is a cloud-based platform for everything that has to do with training, managing, creating, and deploying and publishing your machine learning models. So let's say you want to create an effective machine learning model from the data that you have and you are a non-expert, then you can use the feature which is automated machine learning and such. So to help you get started with your Azure machine learning journey, you can actually get started and sign up by using an Azure free account. So you can actually start free, and you actually, as you start free by using this link that I have for you, aka.ms/Azure sign up, you can actually get $200 of credit to use within 30 days. And obviously, with that credit, you also get free amounts of many popular other services that you have and are always free. So after your credit is actually done, you've used your $200 credit, you can actually move to a pay as you go model. So you only start paying for only the services that you're using. And then after 12 months, you still keep getting those always free to use services that are more than 55, and you can actually still only pay for what you're using. So I would highly recommend for you to check out and sign up by using an Azure free account to explore and begin your machine learning journey as part of this machine learning for evolving applications series. If you're a student, don't worry. You can also use our link, which is aka.ms/Azure Student Sign Up link, which is also posted in the chat box for you to help any students use their student accounts or university accounts to also sign up for Azure. It still also follows the same kind of process, just basically also you have obviously a $200 credit, and then after you use that $200 credit, it goes for a pay as you go model. So for any students here that we have on stream and such, feel free to use this link to sign up with your student or your university account to get started with a free Azure student account as well. And I would highly recommend for you, if you're a student, if you're not a student, to check out the links that we have in the chat box and sign up and start by exploring the different Azure services that would help you begin, your machine learning journey on Azure. That being said, we are actually kind of almost done for today. However, I would like to kind of end this machine learning for evolving applications series by actually giving you some of my best tips on how you can actually get started in the machine learning field. So let's say you're a student, you're a beginner, you're someone who's only getting started in this field, but you don't know, let's say, how to actually get started. You're confused, there are many resources. Where do you start? So these are my best tips. So the first thing you need to do is to learn the prerequisites. Now, it's very important for you to build the basic foundational knowledge that you have. And obviously, since there is like a wide resource of all these resources, your best bet is to use the Microsoft Learn platform. Now, on Microsoft Learn, we actually have free online learning modules and learning paths for you to use in any tech topic you could literally think of and at any level you're at. So let's say you're a beginner and you want to get started in learning machine learning, or you want to start learning Python, or you want to start learning cloud compute, or maybe you're someone who is advanced and you want to learn more on how to deploy models on Microsoft Azure and such. You have free learning resources on Microsoft Learn that is free for you to access at your own pace and to help you build all the foundation knowledge that you need to know. So you can use the Microsoft Learn platform or link to actually help you access any kind of, to help you kind of build your foundation knowledge in any tech topic out there. And you can also use our Microsoft GitHub curriculum or GitHub basically kind of platform for Microsoft as well, which has free kind of curriculums and projects, and obviously everything from running the code and such. So everything you could literally think of, also you can use that as a resource for you. And for a fun fact, also, I'm going to be posting in the chat box for you the two different the learning module that you have for machine learning and getting started in machine learning and continuing your journey after this machine learning series, and also a GitHub machine learning for beginners curriculum that is absolutely free for you to use. It's a free guide for you to actually continue your machine learning journey if you're only getting started and you want to learn more about everything. Let's say you got lost in a step, you want to go back to like a specific let's say a specific a topic, you can find that in our Microsoft Learning platform that I will have for you, and also the GitHub Machine Learning for Beginners curriculum guide for you as well. So have these as a solid foundational knowledge to help you get started. After that, get yourself familiar with a programming language. As I mentioned multiple times, Python is your best kind of way to get started, and also you can use R. So you can use basically whatever coding language you are comfortable using. You can also use Microsoft Learn to help you get started with learning your first programming language. So after that, it's very important to be familiar with all the machine learning algorithms that are out there. So obviously, um, you will have different problems and different tasks that you need to build. So whether it's a regression problem, classification, clustering, neural networks, and such. So you need to be very familiar with all the different machine learning algorithms and when to use each one for that. Next, it's very important to actually take all this knowledge that you've applied and actually apply it using a hands-on project or a real-world example. So find a data set that you love online and start actually practicing. So practice is actually what makes you perfect. Lastly, it's very important to actually connect yourself with an AI or machine learning community. So obviously, try to find any kind of meetups or conferences, or maybe like any workshops or seminars that are around you in the area. If not, try to find online communities such as what we have here on Microsoft. So we have a Microsoft on Meetup kind of group, and we also are all here connected on live stream through chat box and such to actually learn more about each other and what we're passionate about, and to even share any kind of like-minded ideas and exchange any new opportunities in the field and such. So it's very important to have a community and to always keep connecting and networking yourself, to always have the confidence to build all these new amazing projects and share those ideas with like-minded people. So these are my tips on how you can actually get started in AI and machine learning. That being said, as I mentioned, these are the two kind of learning modules that I have here for you today that are excellent learning paths for you to continue with your machine learning journey for this machine learning for evolving application series. The first one is aka.ms/exploreml, which is the learning module for beginning with using data science for machine learning. Excellent guide for you to have and to understand everything you need to know. And the last one is the Machine Learning for Beginners curriculum, which is the guide that has everything you also need to know for machine learning, from different algorithms, models. It has projects that you can see examples as well. So highly check these two links out. That being said, we're actually done for today. Thank you all so much for joining us this far. And I am going to go back to the questions section to see if we have some time, a minute or two, to answer any questions we have. And we are good to go. Thank you all so much for joining us. And I will be on to the chat to see any questions. So, what tips would you give someone who's only getting started in the field of machine learning and building their first model? Thank you so much, Liam, for this great question. Now, as I mentioned, the tips that I already kind of mentioned are actually what cover your question. Now, it's amazing that you ask this question because it's kind of very broad, and obviously you can actually get lost, with all the different kind of tools and technologies and the different kind of, let's say, resources that you have. However, if you're only getting started and you're a complete beginner, as I mentioned, take on the tips that I just mentioned. So start by learning and going through everything that you need to know about on our Microsoft Learn platform. Use the GitHub Machine Learning for Beginners guide to help you serve a purpose and understand exactly what it is you need to do, to understand all the different workflows and the different, subtopics that you have in the field of machine learning. Connect yourself with the community. It's very important. Community is absolutely very important. And of course, be very familiar with starting, have the confidence to actually go ahead and start building your first machine learning model by actually taking through some hands-on examples and projects and actually building them. It's okay, you might get lost on some steps and such, but it's all about practicing and such, and that is the best way to help you actually get started. And what else, what other questions do we have? I think It's amazing to see that we have. Thank you so much, Usushi, for this comment. I have done kind of similar for non-customers, but couldn't use all the steps mentioned here. Now I can do it much better. Thank you so much, Usushi, for your comment. I'm very glad you found this kind of guide very helpful. And obviously, this is absolutely it's a great way to help you actually get started by using all those steps that you need to keep in the back of your head once you have any data set that you have, such as loan customers or such. So thank you for your comments. And lastly, what sorts of hands-on projects are good to start with as a beginner? So this is a very good question, actually, and you can find many good actual hands-on projects online. So one that we always see is actually we have fraud detection, customer and fraud detection. This is something, this is very medical insurance, also cost prediction. We also have, there are many out there that you can actually see. We have the kind of, also the Hello World, also kind of code, which also falls underneath the different kind of flower types and such. So we have many regression and classification kind of projects that you can find. If you can just go online and search let's say beginner hands-on projects for machine learning, you will find an absolute list of amazing recommendations that you can also get started with, like Netflix recommendations, predict weather forecast predictions as well, customer segmentation. So there are out there. So get started with whatever project it is, and be confident, and I'm pretty sure you will be getting there. That being said, I think we are done for today. That's it for the questions. Thank you all so much, and I hope you all learned a thing or two, and I look forward to seeing you in our next stream. Thank you all so much, and I'll see you next time. Take care, and goodbye, everyone.